Hey guys, we are going to be moving on to section 3. Just a quick preview of what our week is going to look like is we'll do section 3 and 4 this week. We'll do 5 and 6 next week, and the following week we will have a test. All of that will be on quarter 1, which means we'll be able to have all those homeworks and the 2 tests on quarter 1. And so this is your chance. If you didn't do very well on the first test, hopefully you can make up for it in the second test. Again, keep in mind that this is a harder chapter because it's all new information. So make sure you're diligently keeping up with your homework and asking questions when they arise. All right, so we are evaluating limits analytically. So we were evaluating limits last section graphically and numerically, which means we were just looking at what values they're approaching. There's actually an easier way to do it without having to graph it sometimes, and then without having to look at a whole XY input-output chart to see what they're approaching. Okay, so our basic limit theorem says here that if B is a number, okay, and C is also a number, and N is just a positive or integer, meaning it's a positive whole number. Okay, B and C don't have to be whole numbers. They don't have to be positive or negative. All right, so if the limit as x is approaching C, think some value, -5 or something like that, of another real number. Again, notice there's no variable. In the actual function, your function will be here, that B is just a number. So like the limit as something approaches something of 2. Okay, just a constant, no variable there. So think of all linear functions that have a slope of 0. Okay, they're just going to be a constant. Then the limit is that constant. So for example, if I did the limit as x approaches, pick my favorite number, 16, of 24, well, this doesn't really affect because I can't plug in 16. I can't plug in x16. It's a constant. So the answer is just 24. It remains the same. So the limit of a constant is constant. Okay. Now a variable is involved. And so if I do the limit as x approaches C, again, C is a number. Okay. I will actually plug that number in here and my result is C. So an example of that is the limit as x approaches my favorite number 16 of, say, just x. It's just 16. I will replace that value. You're going to plug it into that function. Okay. Same concept here is this is now a bigger, more like a polynomial. It's not a linear function. It could be a quadratic. It could be a cubic. N being a power, any whole number power. What I'll do is I'll just plug in, replace x with C. So an example of that is the limit as x approaches, again, my favorite number, 16 of maybe, say, x squared. Well, that's equal to 16 squared, which is 256. Okay. All right, so here is a whole bunch of examples that we can do. So the limit as x approaches 2 of the constant 3 is just going to be that constant. That's what that theorem said above. All right, is x limit as x approaches -4 of x means I'm just going to replace that with what it's approaching, and it's just going to result in -4. All right. And then if I do the limit as x approaches 2 of x squared, I am just going to, again, plug in 2. And I will get 2 squared, which is 4. And you notice I'm showing work. Even though it's minimal work, like the 2 squared, you can do that in your head. I would need you to write it. Okay, you guys are not the best at showing work, some of you. I need to see all your work. I don't care if you're doing it in your head. Whatever math you're doing in your head, write it down. Adding, subtracting, all of it. Okay, it's evidence that you did it. All right, and again, we'll plug it in here. So I'll do 8 times 4, which is 32. Okay. All right, so if we have this, we're now going to combine concepts. So if you notice, I have something to plug 2 into, but I also have a constant. Okay, so I have 4x squared. I could plug 2 into that, and then I have my constant 3. So what you'll do is you'll do exactly that. You'll do it piece by piece. So I'll do the limit of just one section plus the limit of the other section. You don't have to write all that out. You can, but you don't have to. But I can do the limit of 4 times 2 squared plus 3, and I will just simplify that. 2 squared is 4. 4 times 4 is 16, plus 3 is 19. Okay. All right, and then I will do the same thing here. Now, this is a quotient, so I'll just plug in my numbers the same. I'm dividing multiple limits. I can do a limit of x squared plus the limit of x plus the limit of 2. all divided by the limit of the quantity of limit of x plus limit of 1. I could do it all separate, or I can just plug in 1. So I have 1 squared plus 1 plus 2 all over, that looks sloppy, there we go, 1 plus 1. Okay, just like that. So I have 4 over 2, which is just 2. Okay. All right, so now we're going to get into our trigonometric functions, okay, and our transcendental functions. All right, so again, you're still just plugging things in. So your unit circle, though, is important. So I'm going to just do a rough sketch just in case we need it over here. But I'll do tangent of 0, and I have to evaluate tangent of 0. So 0 is here, okay? That is the ordered pair 1, comma 0. Remember that it's cosine, comma sine. So my cosine is 1, and my sine is 0. Keep in mind, tangent is sine over cosine. Okay, and sine of 0 is 0, and cosine of 0 is 1. So this whole thing is 0. Okay, so that unit circle came in handy, except that was an easy one that you actually might have memorized. Okay, all right, so let's go ahead and plug in on the next one. And so we will do sine squared. My dog is on my lap, and she's not helping. Mickey, stop it. All right, sine squared of 0. We'll see if she comes back. All right, and all right, and so we'll do that. Keep in mind, that means this, okay? That 2 there means the entire thing is squared. Not the 0 squared, but the entire thing is squared. All right, and so we already talked about what sine of 0 was. We said it was 0, so 0 squared is 0, okay? So don't overcomplicate it. All right, and then this one, we're going to plug it in. So I'm going to have negative 1 e to the negative 1, okay? An exponent, remember we reviewed our exponent rules, means I can move it down and keep the power the way it is. You don't have to write that exponent of 1, but you could. And so just negative 1 over e is fine. If you want to plug in a calculating decimal approximation, that's fine too. All right, and then in here, we'll do natural log of e cubed. Keep in mind, exponents can go down in front. And natural log of e is actually 1. So 3 times 1 is just 3. Okay, so we are going to find the limit as x approaches 1 of f of x if we have this piecewise function. And this piecewise function says f of x equals x squared plus x wherever x is not 1, so every single place that x is not 1, and then it equals 0 when x is exactly 1. So that's a piecewise function. We reviewed those a little bit before, so they'll keep coming back. So if you didn't get it in Chapter P, you can get it now here in Chapter 1, and it probably will come back up through some various chapters as we go. Okay? So this problem might look kind of complicated, but it's specifically asking as it approaches 1, not at 1. So if it asks what is f of 1, well, f of 1 would be 0 because it tells you at exactly 1, it's 0. That's not what it asked for. It asked for what is it approaching. So from the left and from the right, as it closer it gets to 1, what value is it approaching? What value is it approaching? And it's approaching this expression here. So for me to look at the limit of f of x as x approaches 1, I will actually just plug in 1. That's an equal sign. 1 squared plus 1 plus 1 is equal to 3. So make sure you're reading correctly. You'll find some, even on the AP test, they'll say, well, what is f of 1? What is the limit? And they'll do things like that. Okay, next example. All right, so we're just going to throw some together, work on these. What you notice, or what you may notice, if I were to try to just directly plug this in, that it would be undefined because the denominator would be 0. And you can't have the denominator be 0. Okay, so I have to do other manipulations. So if you can see what I'm saying, this on the denominator would be 0. You can't have that. That's undefined. So we've got to come up with another plan. So what happens with this is you can actually do the division. Okay, I can actually rewrite this. By the way, the limit has to stick around until you actually plug in that -3. So until you're actually evaluating that limit and you're just doing manipulations, it has to follow your work. You can't get rid of it. Okay, that's its operations. That'd be like leaving off a square root or leaving off a plus or minus sign. Okay, so you can't do things like that. All right, so what we'll do is we're going to factor the top. So we'll review back to Algebra 1. Okay, the top is a quadratic. It does have 3 terms. It's going to factor into 2 groups like this. What multiplies to -6 and adds to +1 would be x plus 3 and x minus 2. You could check that by foiling to make sure that that would work out. And then if you notice, the denominator also has an x plus 3. Since there is an entire x plus 3 multiplied in the top, an entire x plus 3 multiplied in the bottom, they can cancel. So really, I'm just taking the limit as x approaches -3 of x minus 2. And that is defined. I can plug that in. That equals -3 minus 2, which is -5. And if I could learn to write better, you all would probably have an easier time. Okay, so same kind of concept goes in the bottom. I cannot plug in 1 because 1 minus 1 is 0, and that would make the denominator 0, and you can't divide by 0. And so what I will do is I'll factor top. Now this would be more of an Algebra 2 factoring. Okay. Not a hard one, but it's more of a memorization. It's not exactly a process. When you have the difference of cubes, so difference of square is pretty common. Difference of cubes, if there's a minus, you will have 2 sets of parentheses. You'll have a binomial in the first one, meaning 2 terms, and a trinomial in the second one, meaning 3 terms. Your first term is the cube root of your first term. So the cube root of x cubed is just x, minus the cube root of your second term. The cube root of 1 is just 1. Okay, if it was plus, then you'd have a plus sign in the middle there. All right, and then it is your first term squared. Okay, it is the product of your 2 terms squared. Sorry, it's just the product of your 2 terms, the positive product. So 1 times x is going to be positive x, and then it'll be your last term squared. So that -1 squared, it'll be 1. Okay, if that were a plus sign, that would be pretty different. It would change this to a plus sign here, and it would change this to a minus. I mean, I say pretty different, but that's about it. That's all we do. And you could check by distributing that to make sure it would equal x cubed minus 1, which it would. All right. And then your denominator is still x minus 1. If you need to look this up, by the way, this is called the difference of 2 cubes. You can also look up the sum of 2 cubes, but that is an Algebra 2 concept you are expected to know. Just like on the previous one, we have an entire x minus 1 multiplied in the top, an entire x minus 1 multiplied in the bottom. So that is equivalent to 1, so we don't have to write them. We can cancel them out. So this is equal to the limit as x approaches 1 of x squared plus x plus 1, which is actually one we did earlier, and that is equal to 3. All right, last one's kind of a doozy. Okay, so if you notice, I can't plug in 0 again because the denominator is 0. So the goal is to rationalize this in a different way so that there's more than just x on the bottom, or we can get rid of the x out of the bottom so that it's not 0. So if you recall from Algebra 2, you guys use something called a conjugate to rationalize denominators. So we're actually going to try to rationalize the top because we need to do some sort of manipulation to make this happen. So what I'm going to do is I'm going to multiply top and bottom by exactly the same thing. So I'm multiplying it equivalently to 1 by 1. So it's not changing its value. It is changing its appearance. And so I will have the conjugate of the top this time. So x plus 1. And this sign will change, plus 1. And what I do to the top, I do to the bottom. And I'll have x plus 1 plus 1. Okay, so this sign is what changed, the 1 in between the root and the 1. And I will simplify that. So the denominator, I got to keep my limit as x approaches 0. The denominator has now become x times root x plus 1 and then plus 1. And the top, if you were to FOIL that out, root x plus 1 times root x plus 1 is root x plus 1 squared. The root and the squared cancel, so it's just x plus 1. The outer becomes root x, positive root x plus 1, and the inner becomes negative root x plus 1, and the last becomes negative 1. So it's kind of long. You could actually skip writing this. That should cancel every time. Okay, that's how the conjugate works. If you chose your conjugate correctly, that middle term will cancel out. If you notice now, when I simplify this, I have the limit as x approaches 0 of x plus 1 minus 1, because those roots canceled. The denominator is now x times root x plus 1. I don't recommend distributing that x because if you notice, the top, positive 1, negative 1 cancel. I have an entire x in the top, and I have an entire x in the denominator. And so I am left with the limit as x approaches 0 of 1 over root x plus 1 plus 1. When I go plug in 0, I get 1/2. All right, so then I have 3 special limits using trig functions. They're special because you can't plug in 0, but there's not a lot of manipulation to do. So these special limits give you a grounds to do your substitution on. Like you can do your manipulation based off these. So the basic one is if this matches. I can't cancel them out because the top x is trapped by sign. Please don't get in the habit of that. Sign has to contain that x. There's no way to get that x outside of the sign. However, if what is inside the sign matches what is in the other part of the fraction, top or bottom, that whole thing can be flipped. It could be x over sine x or sine x over x, and x is approaching 0, it's always 1. So you can base your manipulations on that. Likewise, the second one is x is still approaching 0. If I have 1 minus cosine of x over x, so again, these match. That has to be 1 minus, or it has to have a common product that you can factor out to make it 1 minus. Then again, those don't cancel because 1, there's subtraction at the top, so literally it couldn't cancel if normally you could. But that x is trapped by that cosine anyways. Okay. And so that is always equal to 0. All right. And then we have one transcendental one. So the consistency of the x's here is really important, and you'll kind of see how that works. So an example that works like this, you wouldn't realize necessarily that the special limits are in these examples because if you notice it's tangent, and none of those special limits have tangent. However, keep in mind that I can rewrite this limit as sine x over cosine x. That's the tangent, and it's still over x. So you see I have sine over cosine? Okay, that's important. Now, I have a fraction within a fraction. Okay, so if I wanted to keep that idea going, the top could be sine x over cosine x, the bottom could be x over 1. When you're dividing by a fraction, it is the same as multiplying by the reciprocal. So I could rewrite this as a limit as x approaches 0 of sine x over cosine x multiplied by 1 over x. So I flip it. So 1 over x, instead of writing the 1 is multiplied in the top, so I'm not going to change anything. And the x goes multiplied in the denominator. I'm going to put it there to not get it confused with the x that's in the cosine. You cannot combine those x's. That does not make x squared. Okay, that is x times cosine x. That x is trapped by the cosine. The other x is outside the cosine. Now, if you notice, I have a sine x over x, which is exactly that limit, and my limit is approaching 0. So that whole thing, that's actually 1. Okay, so I can actually do parts of my limits, and I now have 1 over cosine x. And for that, I can plug in 0. And in my unit circle at 0, it is cosine comma sine, as we talked about before. And so that's just 1. So this is 1 over 1 or just 1. Okay, so there's that manipulation that can go on there. So this one more resembles the rule, but if you notice, this has a 4 here in the sign, trapped inside, and the bottom doesn't have a 4. So I would need to manipulate in such a way so the bottom does have a 4. So what I'm going to do is I want the bottom to have a 4. So I'm going to multiply the bottom by a 4. But again, to keep things balanced, I need to multiply by an equivalent of 1. So I'm going to multiply the top and bottom by 4, because 4 over 4 is 1, and it doesn't change the value, it just changes its appearance. So I can rewrite this as the limit as x approaches 0 of 4 sine 4x all over 4x. And now that this matches here, the sine 4x and the 4x on bottom, this whole thing can become 1. And then I plug in 0. There's not an x value to plug in 0 to. So again, the limit of a constant is just that constant. And I get just 4. Same kind of thing could go for the 1 minus cosine x. Say it was 1 minus cosine 4x over x. Again, I'd multiply top and bottom by 4, and then that whole thing would be 0. Same kind of thing would go for number 3. If I were to have, say, again, that 4x, it would need to be 4x on the inside and 4x up to the exponent. So you'd have to figure out ways to manipulate it. Number 3 is very uncommon to see. Okay, but it is important to realize because it might be a multiple choice question on AP test or something like that. All right, that is the end of these notes. Again, reminder that we are looking at having a test in not this week. We'll do 2 lessons this week, 2 lessons next week, but the last week of the quarter, which ends on the 19th. No, the next quarter starts on the 19th. 16th, you will have a test on October 16th. So keep that in mind as that comes up. You want to be well prepared. You're going to have 3 homework assignments due this Friday. This one, section 4, and last week, section 2, because we did that one a little later in the week. Make sure you message me with questions. Have a good week.